Good day, everybody. Brian here from quantlabsnet.com. I want to talk about another basic but highly important equation when it comes to futures options calculating for the quant. Many of the firms will have their own, well, usually a modified version of this, but this is where they start. Um, and I want to talk about this important formula called the Black-Scholes. And I just want to show you the what I've got developed. So in here, I'm using oil as a sample. We have here the price of oil. I think this is gold actually. Um, and in here, what we've got here is the things that we can calculate using Black-Scholes. Now, I'm not going to tell you how it works or what it is, but the important part is the parameters that are used as the input. So we have here, now again, this is for options trading. We have a call option price. We have our current stock or underlying price, strike price, the risk-free interest rate, time to maturity, and the normal distribution. Okay, so this is off of Investopedia. So if you want to know more about it, go there, go elsewhere, whatever you want. Some people say this is not good enough, but usually it's probably one of the better ones just to get an idea how accurate it is. So in this case, we have a call option price of 23.8936 theoretical, put option price at 929.20. Uh, that began theoretical. I've already done a video on capturing option chain data for uh, the different contracts and that for the different call and puts and at different strike prices. I'm not going to go over that, but I'll just say from a programmatic standpoint, it's difficult to capture unless you're willing to pay for it. And I've got a couple of videos on that and better description on my blog as well for that. And really, you have to eyeball it if you're doing this on a budget, unless you're willing to spend 2 to 4,000 a month US plus the licensing on a 1 year contract. So it's running 25K, 50K just to get the data that you want depending upon your frequency. So here, with the Black-Scholes, the predictions are remarkably close to the actual market prices for both the call and put options. Um, Again, the power of Black-Scholes. Okay, sorry. So here it gives you the price for comparison on the call price and the put price. So I could use that as part of the option chains to get better simulation. Um, if I want. I haven't really thought about that yet, but I could do that. But it won't be accurate. But if I'm using the Black-Scholes, it could be close to it, but it's theoretical. But that's kind of what I've got for now. Anyway, so the Black-Scholes provides a robust framework for providing option fair value. Accuracy helps traders identify potential trading opportunities, buying undervalued options. That's part of the goal here, or selling as well. Depending upon you just flip everything backwards. But it's really for the buying option. While limitations exist, constant volatility assumption, because again, if I was to show you the live option chain with the bid and price, yeah, it's pretty tough to measure. But again, we're just trying to guesstimate here uh, as best as we can with Black-Scholes. So, despite the constant volatility assumption, it remains a valuable tool for understanding options and making informed investment decisions around that. One of the other things is if you know how to, in the math side, you can use the Black-Scholes. Where's the formula here? Right here. You can manipulate this to calculate things like what will the implied volatility be, that sort of thing as well by calculating this right here. So you can do that. A lot of people do that as well. So there's different methods here. So here, as you can see here, it doesn't quite give you the full-on explanation of what this means. That's your standard deviation. So let me just go back here. That might be a better one. Let's go to Wikipedia because we want to see um, what that standard deviation stands for. Um, so these are all the different movements in the market, all the different call options, put options. This gets more sophisticated as well. So maybe the Wikipedia might be helpful. And again, you get into all the fun stuff, the delta, gamma, vega, theta, rho, which I can get into in another video, which I will. But it just depends. You can see how it's very, very formulaic and measuring skew, Black-Scholes as well. So this can be a good article as well. Commenting's the best as well, and people criticizing it as well. Our famous Nassim Taleb. But we'll leave it at that. If you want to know more what I do, just come over to my website, quantlabsnet.com. I'll put the link in the description. Click on Learn and fill out your info. I don't resell your info. I don't release it to anybody. And you'll get uh, blog posts emailed out to you when I'm working on. So under more blog at the website, quantlabsnet.com, you can see all the different topics here. Again, sometimes I'll release videos on arbitrage and the last one on hedging, efficient frontier, all that stuff. But there's going to be more information about in the blog. So here, as an example, I don't think I might have talked about. Yeah, I did talk about it, but here this goes right into specifics on what I mentioned about the option chain data being very very expensive, 2,000 or 2,500, 4,000 per month. Okay, plus the term, plus the licensing fee. The CME and the ICE, uh, they guard this data very carefully, and there's very few operators that allow that to be sent to be uh, um, worked with and manipulated, and but you got to pay, okay? And yes, you can order the same data from the exchanges as well, but again, they're expensive, long-term contracts, da da da. Anyways, I'll leave it at that. If you like this sort of stuff, just come over to, again, the Learn tab at the top, quantlabsnet.com, and fill out your info. Other than that, thanks for watching. Have a good day. We shall talk to you later. Have a good one.